Hi, I'm Philip. I'm an ML engineer at Superlinked, and we are an open source framework in Python that solves the problem of accurate retrieval in AI search and recommendation systems. We have an open source repo, which you can try. So we have a quick start and a lot of notebooks. But the quick overview would be this. So we basically sit as a layer on top of vector databases, and we do different types of encodings depending on different data types. So what this means is that with Qdrant, we were able to build very cool use cases, and we have a deep dive article on it. So we have this hotel search example that you can have a look at. So we handle complex queries like this one, affordable luxury hotels near the Eiffel Tower with lots of good reviews. And here you can add free parking or price below $200 and so on. And that enables you to do things like this, where you can ask a query that has a lot of different contexts on different data types. For example, cheap is related to pricing, so you would need to include pricing data. Highly rated hotels is related to ratings, so you would need specific data related to ratings. Also, London to location. Then there is negation, and also if you add price, if you add categories, if you add images, this can get quite complex, especially with this complex queries. So what we do is we have this approach of mixture of encoders, where depending on the data type, we use a different encoder to encode that data and then aggregate everything into one vector where we concatenate the embeddings generated by each encoder. So for numbers, we use a numeric encoder. For categories, we use a categorical encoder, a text encoder, image encoder, and so on. So we have lots of different types of encoders that then we mix, we encode the data, and generate one concatenated vector, which has these embeddings, these sub-embeddings that relate to different aspects in the data. And in the hotel demo, this means that when you also search for something like cheap, we can weigh these subvectors generated by different encoders. So here you can see that the price weight has a weight -1. So we were able to recognize that cheap relates to lower price. So we're able to bias the ranking of the retrieved results towards this. And we do purely vector search. So that's why Qdrant has been very useful, because we aim to think that the problem of accurate retrieval can be solved if you generate good enough of embeddings. And also we have a lot of integration, so you can have a look in our core repo. So we have this Qdrant connector. You can find it in frameworks and storage. So this is a mix of query translation. So we have the Qdrant query builder, basically, that translates the Superlinked internal code, basically the Superlinked's internal search parameters, into Qdrant specific ones. Then we have search execution. Then we have data mapping, of course, where there is some entity data transformation between the Superlinked format and Qdrant's, I think, point structure. That's what's it called. So we have also index management. So Superlinked manages the Qdrant index. So you can have a look at all of these here in different in different files. So the search and the index management that I mentioned. And in an applied scenario, in the hotel search example that I mentioned, you would look into something like this, where you would need to install, if you work with the Superlinked server, everything is bundled in together. So you just need to install this. However, if you're using like a notebook to run Qdrant, you would need to install Superlinked and then brackets Qdrant in order to run things. And this is the example of the hotel demo that I just showed. We also have a deep dive with Qdrant where I explain in more detail how that works. So feel free to have a look at that and also look at the article that I mentioned. That also explains the core components here and this preference. And in the hotel search, we have a more applied use case of Qdrant. So you can see that in the config, we set up the URL and the API key, and there's an example config that you can use. We also have the API, and this is the Qdrant vector database class, which is implemented in the code and the section that I showed previously with all the query translation and connector building. And our collaboration has been very useful, where we were able to look at a lot of different use cases in search and recommendations. And you can go to our repo. So here, this is your one-stop contact or one-stop point for Superlinked, where you can have a look at also at our docs. So we have a lot of resources that would help you build with Superlinked and how we run in production. So we do everything from schema design to custom DSL to then there are ways to deploy this as an API, and then we have a cloud offering that you can build on top. So it's a nice combination of resources that you can find in our docs, but the repo has a lot of resources in itself. So this is the minimum quick start example. And then there are a lot of notebooks here that you can learn to build stuff with Superlinked and then run them in production with Qdrant. So I'm happy to answer any questions. Feel free to try these notebooks and learn how to build recommendation systems and how to use this approach of mixture of encoders to generate better embeddings. And then when you're ready, when your embeddings are generated, you can run things with Qdrant Cloud in production. And I'm excited to see what you can build with your AI search and recommendations use cases. Thank you.